Thank you all for joining. This is my presentation on building resilient telemetry pipelines. Let's kick in. So, quick agenda. We're going to do some quick intros and overview, dig into the persistent queue under the hood, look at some frequently asked questions, like questions that I get frequently asked, quick recap, some asks that I have then for you all, and then if there's time, Q&A. Cool. So who am I? Denton Krietz, based out of Ann Arbor, Michigan, and I am a sales engineer for Bindplane, which means I work with customers every day on the OpenTelemetry Collector, getting it deployed at scale and so forth. So I have at least some experience working with the persistent queue. When I'm not working in OpenTelemetry and telemetry pipelines, you'll often find me at the Pottery Studio. So feel free to come and chat with me about that as well. All right. So why am I giving this particular talk? Today happens to be my wife's birthday. Sadly, I'm not with her, but she told me her one and only wish for her birthday is for me to spread the good word of OpenTelemetry and help somebody have a more resilient telemetry pipeline. So I feel like what better place for me to be than here giving this talk. So hopefully that happens. If we had more time, I'd have you all sing, we could record it, but I just don't think that's gonna work out. So, but for real, why are we here? Why are we talking about the persistent queue? And so this is really to protect against data loss in your OpenTelemetry Collector-based telemetry pipeline. And this data is buffered before it is exported, and there's a number of reasons why you could lose data in the process. The collector crashes, there could be some downstream outages for some reason, but there could also just be sort of traffic spikes. Nothing has to be technically going wrong, but there could be reasons why there's excessive load on your telemetry pipeline. And so one might ask, like, why queue data in the collector to begin with? Right? Maybe there could be a better option or an alternative of like maybe you never queue it at all, and then you don't have to worry about that queue being persistent. And I think that's a reasonable question, and I think there probably are scenarios where that's actually a really great way to think about it. But there are also a lot of situations where that's not an option. One of the most common is when data is being pushed into the collector. And so it can be really challenging to tell those upstream systems, hey, stop sending me data. They're going to just keep sending data. So that's a great reason to then queue that data up when there are those issues downstream. There's also certain sources that simply don't handle back pressure very well. And those two things are sort of one and the same or tightly related, right? So again, we're going to sort of continue with this talk assuming that it makes sense to queue data on the OpenTelemetry Collector for reasons that we've talked about. And so how do we do that more resiliently so that we can try as best as possible to not lose data, right? And I'm not much of a meme guy. This will be the only meme in this talk, but it felt really applicable as I was preparing for this talk. As you start digging into the underlying components in the collector, or I'll speak for myself, when I start digging into the underlying components of the collector, it really started to feel this way for me. You start thinking about topics such as asynchronicity and how does that play into these various components? How does concurrency work? How does batching work, and what are the implications there? There were many rabbit holes that I could have went down, and I tried really hard not to and keep this talk pretty focused on the persistent queue and how it works and so forth. We'll see a couple minor rabbit holes, but again, my goal is to stay out of those as much as possible. Cool, so let's dig in. This talk very much assumes that you have a at least decent understanding of the OpenTelemetry Collector. If you don't, this is going to be a little more challenging, not impossible, but certainly a bit more challenging. The collector has a number of these components. We've got receivers on the incoming side. We've got processors in the middle. We've got exporters on the right-hand sort of downstream side of things. This is my entire overview of the collector. And mostly I put it in here just to sort of point out where we're going to be focusing. And again, that's really on that sort of right side of the collector. As data is being exported out, when there are challenges and issues, that's where the persistent queue is configured and comes into play. Cool. So continue on with sort of an overview of this. It's really helpful to understand the two key components of the persistent queue. We've got a sending queue in general, and then we've got a storage extension to go along with it. So the sending queue is basically a first in, first out memory queue, right? And so when there's no storage, all of that's handled in memory. It buffers requests before they're being sent or exported. And there is a level of concurrency that goes along with the dequeuing. So there are workers that are dequeuing messages off of this queue and then going through the rest of the export process, retrying, timing out, and so forth. Right? When we pair that up with a storage extension, we now have some durability with that. It's no longer based solely in memory. And so, again, that queue is actually living on disk in those situations where the collector would crash or there'd be issues. And there's actually a number of storage extensions available. We're going to focus almost exclusively on the file storage extension. It's the one that I have the most familiarity with. Again, working with customers that we roll out to, that is pretty much the main option that's there. But there are other storage extensions, and we'll talk about that a little bit more. And so when a sending queue and a storage extension fall in love, we get a persistent queue. Yeah, we could really stop it right there, and I think that's the real takeaway here. No, but seriously. So where do you find these when you're looking around the various repositories and so forth? Sadly, even with that love, they do not live in the same place. The sending queue, all of the code, the documentation, and so forth, you can find that in the core repository, and it's all under the exporter helper. Right, so this is a number of features and functions that are used by pretty much all exporters in the OpenTelemetry Collector. Right, we're not going to talk about all of those features. Like I said, I'm going to keep it focused on the persistent queue. And then the storage extensions themselves, you're going to pretty much find those in the contrib, the OpenTelemetry Collector contrib repository. And again, like I mentioned, there's a couple that are in there right now. The file storage is the main one. There are ones for SQLite and Redis as well. And actually, just in a previous talk about an hour ago, there was confirmation that we've recently seen the Redis work as a storage extension for the queue, which is really exciting. In testing in the past, that hasn't always been the case. So I'm really excited to see some more expansion there. Cool. All right, so let's go just a little bit deeper into the configuration for these various components and talk about how we think about tuning and tweaking some of the functionality. So this is straight out of the documentation on the exporter helper, right? This document or this diagram. And I think this actually does a really nice job of sort of highlighting, at the end of the day, this is not an overly complicated system. But there are some sort of key pieces here that are highlighted in this diagram. You get that sense of the first in, first out nature of the queue. You also get that sense of concurrency, right, with the multiple consumers pulling data off of the queue. And another actually call out that I only just sort of recognized more recently is how each one of those consumers is responsible for its own retry loop. So you see that down on number 4, right? So once that data is dequeued off of the queue, that consumer is going to sit there and go through its own sort of retry loop as it's trying to export that data out. So as opposed to, say, re-queuing it and having it come back and so forth. There's different ways that could be handled. All right, so let's look at some of the primary sort of configurations here. Again, so these are the parameters that are available for the sending queue, obviously enabling it. This is an important call out. This actually just caught me the other day. This defaults to true, so as in the sending queue is enabled by default in the exporter helper, but that doesn't necessarily mean that it's enabled by default in the exporter. So be mindful of that when you're configuring your exporters. Take a look, see if they have changed the default. Like I said, I was caught off guard just the other day by that. So the number of consumers is exactly as the name implies. This is how many of those consumer workers are actually dequeuing data and sending it off downstream. This defaults to 10. This is one of the parameters that we often find ourselves tuning while we're working with customers to get sort of that just right value to not overwhelm your downstream system, whatever that might be, but to make sure you're efficiently exporting that data. So I can't give you a golden number to always try, but it is definitely a place to tune and be aware of to make those pipelines more efficient. All right, the queue size, we're going to get into this a bit more in the FAQ section, but this is the number of things in the queue, and I say that'll make a little more sense in a second. But this is, yeah, so this is how big can the queue get? And then storage is, as we've been talking about, this is where you would name your storage extension. All right. These two, that, my friends, is a rabbit hole. And this is one that I started to go down and realize there's not enough time for this talk to get into this. But I do want to make people aware of these two configurations. So wait for result and block on overflow. So both of these really play into, this is broader than the idea of a persistent queue. This gets into conversations around back pressure and how that's handled in the queue. And again, that's honestly a whole nother talk on its own. So I put these up there for folks to be aware of. But again, there's more there to dig into, right? Maybe that'll be the next talk. And then these two are really in here as teasers. Again, this is not going to be the focus of the talk, but this is really exciting work that's in progress right now in the exporter helper. So the two things here are, one, the sizer. So when I said a minute ago about the batches being default to 1,000 things, what I meant by that is in the past, it's always been 1,000 batches, right? Or in this case, they're called requests, so batches of data. But the addition or the new features and functionality is the ability to base the queue based on the number of items as well as by size or bytes. I'm really excited about this. Again, it's new enough. I don't have a ton of experience, but I want to call it out so people are aware of it. And then the final one here is the batch itself. So currently, but again, what I am most familiar with is batching data as a processor. that is actually moving into the exporter helper. So all of that batch functionality, again, is shifting into the helper for reasons, more than I have time to go into. All right, we're gonna do this one a little bit quicker. So the file storage extension, I'm not gonna go through each one of these, but this is how you configure a file storage extension. Pretty straightforward. It's mostly pointing at a couple different directories, as well as some values around compaction. And again, I'll get into that a little bit more in the FAQ. All right, here's 2 quick sample configurations. Setting up an OTLP exporter with the sending queue portion. So again, the sending queue and the persistent queue is enabled within your exporter. And then there will also be the file storage extension, assuming, again, you're using the file storage as opposed to one of the others. All right. And I want to call out that there are a number of metrics available for monitoring. And the one that I really want to highlight, which I have highlighted, is the OTel Collector queue size, right? So this is a metric that will tell you how big is your current queue. And this doesn't necessarily need to be 0, but it is something you want to be aware of if it is growing and that is unexpected, right? Then if there's not an outage, then your pipeline's not keeping up, basically. The exporting is not keeping up. So definitely recommend monitoring these metrics as a way of understanding the health of the pipeline and the health of the collector. All right, so let's get through some of these FAQs. So again, as a customer-facing engineer, these are the kinds of questions I get asked about the persistent queue, and so hopefully they'll be useful for everyone else as well. So one of the big ones is the file size on disk is not decreasing. Is my data getting sent? That's a really logical question. You know this data is getting written to disk. You would expect as data is being dequeued that file would shrink, and that's not going to happen automatically. And that's because the underlying file storage mechanism has a compaction process. So it's not going to, as a item is dequeued and deleted, that file doesn't automatically shrink in size. Bbolt, which is the underlying database that's used, needs to go through a compaction process to then reclaim that allocated but unused space. And I'm looking at the time. I'd love to sort of walk through that process, but I don't think I'm going to have time. So trust me, it does that. The docs do a pretty good job of explaining sort of how that goes. Basically, you've got those 2 primary thresholds. How big does the queue need to get before you're saying, I need to compact this? And then how much smaller does it need to get before you actually kick off the compaction? So don't use the file size, use your metrics. So how should I size the queue? We get this question all the time, and it's a really reasonable question, especially when you're talking about batches. There's not an easy sort of correlation between a batch and size on disk. So again, this is how we sort of work with this. The 2 ways I've seen this work best is either taking a extremely conservative approach and have an understanding of the sort of maximum size of one of your pieces of telemetry, say a log, right? You multiply that by the number of messages in your batch, and then you use that number to sort of calculate the size of space on the number of batches to the amount of space on your disk. The other thing that I would like to call out, and I feel like this is a little hidden, a lot of this can be hidden in the docs, but I feel like this one's really hidden. There is actually a detailed level metric in the batch processor that can give you the batch send size in bytes. So you have to enable detailed metrics, but that will actually allow you to track the size in bytes of your batches. So from that perspective, you could then get a much better sense of sort of how, on average, how large are your batches, right? And then again, use that to sort of calculate, well then, if I've got this much space and these many batches at this size, you can sort of work backwards from there. Add a little bit of space for compaction, right? And that's how you sort of size your disks in regards to batch sizes. And another comment there on the sizers, I'm really excited about that. Again, depending on how that sort of plays out, I know there are comments in the code around it not being as performant. I'm still looking forward to hopefully setting your queue based on disk, bytes could end up making this a whole lot easier. All right, cool. I know we're getting close to time. I'm gonna go through this one really quick, mainly because I'm not a Kubernetes guy and I don't want you all asking questions of me about Kubernetes. There are ways to have persistent volumes within Kubernetes. Use them if you're trying to create a persistent queue. From an auto-scaling perspective, right, the biggest concern is scaling down, and so we need to be really mindful of not scaling down when the queue has data in it. So your CPU and memory might not be a very good indicator of it's time to scale down, but we know the collector has metrics that can be used to handle some of that. All right, real quick, data, what data will be sent first? It's a first in, first out queue, whether it's a memory queue or persistent queue. So when your downstream system is restored and data starts sending, it's going to send the oldest data first, because that's the data at the earliest part of the queue. Awesome. And last but not least, how long has it taken me to grow this beard? Guys, focus. All right, we've got more important things to talk about, but it's been about 6.5 years, in case you were wondering. All right, thanks. Real quick recap and my ask of you all. So I think at this point, it hopefully is pretty clear on why this is important, and this has given you a better sense of how to get started, or at least where to look for more information around all of this. Our sending queue is a great start, but it's the most basic form of resiliency here. And I would say the even more important takeaway here is the persistent queue is not a silver bullet. It is one mechanism for resiliency within a telemetry pipeline, but there are other options, and again, depending on your situation, there could be better options. We started talking about back pressure a little bit. So I think it's a great way to add resiliency, but be mindful of other options. Finally, my ask of you all, if anybody has done significant sort of testing around like hardware performance, in general, it feels like storage is just good enough these days that I've never seen anybody run into issues. But if you have, let me know. I'd love to hear about it. And anybody with more experience with the alternative storage extensions like Redis or a database, again, I'd love to hear about it. At Bindplane, we're going to be doing a lot more sort of research and development around those things. But if you're already doing it, yeah, come and chat with me. We do have a booth out there, so stop by, talk to us, ask more questions. The standard QR for feedback, I think I actually went over, so I'm glad there's nobody here giving me that. Yeah, perfect. We're good. So no time for questions. I'll be at the booth. My colleagues will be at the booth. Thank you all so much for coming.